Okay, let's get into talking about simplifying expressions. When we want to simplify expressions like the ones that you see here, what we have to do is look for like terms. So here are just a few things to know when you are starting to learn this skill. Any number that is with a variable, that is what we refer to as the coefficient. So it's just that number that's out in front that's being multiplied times the variable. If you have a number that is just by itself, doesn't have a variable attached to it, then that is a constant. And then as you can see, these two things are separated by a plus sign. When you have two things that are separated by a plus or a minus sign, then those are referred to as terms. So all of the things that are grouped together that are being multiplied together, such as the number and the variable, would be considered a term, or just one of the numbers by itself would be considered a term. And so when we're looking for like terms, these things are what we're looking for, these things that are being separated by either a plus or a minus sign. So here are some examples of like terms. These two, 7c and 5c, these are like terms because they both have the same variable. They both have c. It has nothing to do with the numbers themselves. One of the common misconceptions that that students have that I work with is if both terms are positive, then they are like terms, or both terms are negative, then they are like terms. That is not the case. It is solely dependent on the variable. Another misconception that students have is when exponents are involved. These two are like terms because they are not only both x's, but also have the 2 exponent that goes with them. If this was just an x and didn't have the squared here, these would not be considered like terms. We're going to go over some other not like terms in just a moment down here. These are also going to be considered like terms because they both have a and b. So this one, although it has a coefficient out in front and it is negative, this one does not have a coefficient. It has an understood coefficient of 1, of positive 1. We just don't normally write the 1 when the coefficient is 1. But these are like terms because they both have a, b. A and b are being multiplied together in both of these terms. Okay, so here are some examples of not like terms. So again, like I said, here we have an x just to the singular exponent, or we don't normally write 1 as the exponent, but that's what it is. It's an understood 1. So x and x squared are not like terms. Yes, they both have x in them, but because this is just a singular x and this is x squared, that's what makes them not like terms. Here we do not have like terms because this one has a and b, and this one just has a. So again, notice that I'm not pointing to the numbers, the coefficients out in front of these at all to determine if they are like terms or not. It has to do with the variables, and the variables have to be exactly the same. Here we do not have like terms with c squared and d squared. Yes, they are both squared, but they are not the same variable, c and d, so those are not like terms. All right, let's go through and work some of these problems. So let's see. One of the things that I really like to teach students to do is to separate out your terms. When you have, especially when you have a big long string of terms, it can just feel visually overwhelming. So one of the ways that I like to do that is just to make like a big slash in between. Now notice I'm making this slash in front of the plus sign here and in front of the plus sign here. Whatever sign, whether it's plus or minus, that is out in front of the term, that goes with that term. So 3x is positive since we don't see anything out here in the front. We've got a plus or a positive 2, and then a plus or a positive 5x. Now, let's see if we can identify which terms go together. Well, I see that this 3x has an x right here. The 2 does not have an x, but the 5 does have an x. So these two would be able to be combined together. And again, we're just looking at those signs out in front of each term. So 3x plus 5x is going to give us 8x. Okay, so notice that we added the 3 and the 5 together to get 8, but the x just stays x. So it's not x squared, we are just adding them together. So we're trying to figure out how many x's we are multiplying together. We've got 3 x's over here. We've got 5 x's over here. So that gives us a total of 8 x's, or 8x. And then the 2 doesn't have anything else to add or subtract with it. So we're just going to drop that down as plus 2. So that is our answer, 8x plus 2. We can't go any further with that because these two are not like terms. They don't have the same variables, so we can't combine them. And these are not equations, so we can't solve them. Let's go on to problem 2. Another way that I like to separate these out, I showed you the slashes before in problem 1. In problem 2, one of the things that I like to do is identify the different like terms and put different shapes around them. So let's say I've got a y term here, and then I just want to scan through and look for any other y's. Oh, I've got one right here. So I'm going to make sure to include that sign that's out in front of each of those terms. I don't have any more y's, so now I'm going to go to the next term. Okay, and the next term I see is a b term, so I'm going to give that a circle just so that it's a different shape. And then I'm going to scan through. Oh, I have another b term right here. And then the 4 is by itself. I don't have anything else, so maybe I'll put a triangle around that. So just some shapes, some different shapes, so that you can visually see, okay, well, these two go together because they're both in those rectangles. These two go together because they're in the circles, and then this one is by itself. There are no other terms that have a triangle around them. Okay, so let's start combining our like terms. We've got 10y, a positive 10y, and then minus 5y. So I'm just going to look at the numbers first. 10 minus 5 gives me 5, and then that y is going to stay with that. All right, now let's go on to the next one. We've got a positive 7b and a negative 2b. So positive 7 minus 2 gives me a positive 5, so I'm going to drop down a plus 5, and then the b stays with that term. And then the 4, it just gets dropped down as well. We don't have anything else to add or subtract with that 4, so we just write down plus 4. And that is our simplified expression. Okay, number 3, it looks like we have w's in all of our terms, but some of them are just a singular w, and some of them are w to the power of 2, or w squared. Okay, so another way that I like to separate these visually, I'm just showing you different ways, and then you can pick whichever one you like the best. I will go through and look for the highest exponent. So in that case, it is the 2 exponent, or the squared. And I'm just going to underline those terms. And I'm going to make sure to underline the sign that is in front of each of those terms. And that way I can just kind of identify, okay, those are what I want to start with. Whenever you are starting to simplify these, if you do have terms with different exponents, you want to start with the highest one and then work your way down. So let's see what this is going to give us. 6w squared plus 2w squared. So I'm just going to add the numbers, the coefficients together. So 6 plus 2 is 8. And then that w squared stays with it. So again, nothing has changed with the exponent. I'm continuing to use that same variable portion of these terms with my simplified expression. Okay, so now I'm going to cross those out because I've used those two. Now I'm going to see what's left over. Okay, now I just have 4w and then another minus w. So I'm going to put those together. So positive 4 minus, this is minus 1w. This is a coefficient of negative 1. We just don't normally write the 1 when it is a negative 1 or a positive 1. We'll just write it as negative w or just w. So 4 minus 1 gives me 3, positive 3, so I'm going to write plus 3w. So again, I've just kept that same variable with that simplified expression, and this is as far as we can go because these two are not like terms. We can't combine them or go any further with this expression. All right, let's continue on. We've got some that are a little bit longer and we have some more variables in these. So let's go ahead and use one of those methods to just sort of visually separate these terms out. I'm going to use the slashes for this first one. So I'm just putting a slash in front of each plus or minus sign because this minus sign goes along with this 3x, this plus sign goes along with this 2y, and so forth. So let's go through and identify any like terms. So I'm just going to start here. I'm going to underline, I'm going to kind of combine a couple of my, my methods here, 9xy, and I'm going to scan through. I don't see anything else with both x and y. Yes, this has an x, this has a y, but in order for it to be a like term with this 9xy, it has to have both xy with it. So 9xy is just going to be there, whoops, by itself. It doesn't have anything else to add or subtract with it. And then I'm going to cross that out because I'm done with that first term. Now let's go through and take a look for some other x terms because I've got negative 3x. So I'm just going to scan through, and here's one with an x term. So, and that's all that I have with just x terms. So negative 3x, negative 5x, when I combine those together, I get negative 8x. And if you're not sure about adding or subtracting positive and negative integers, I do have a video, I'll link it in the description, with some different strategies of how to add and subtract positive and negative numbers. Okay, so we've done our x terms, and so now I'm just going to move on to my y terms. So it looks like I just have these two, positive 2y, positive 3y. When I combine those together, I get positive 5y. Okay, and that is our simplified expression. On to number 5. For this one, let's see, I'll use the shapes. So I do see that some of these have some exponents. So I'm going to start with those higher exponents. I only see m as the variable. It's either m or m squared. So I'm just going to start with the exponents, the highest exponent, which is 2. So I'm going to go ahead and circle those. And then let's see, m is going to be next. My m terms, and again I'm boxing the signs in front of each term, and then it looks like the 10 and the negative 7 are constants. Okay, so let's start with those m squared terms. So positive 6m squared plus 1m squared gives me 7m squared, and so I can kind of cross those out. I'm done with those. And now we're going to go down to our m terms. We've got negative 2m and a positive 5m. So negative 2 plus 5 gives me positive 3m. I'm going to cross those out. And then all I have left are my constants. A positive 10 minus 7 gives me a positive 3, so positive 3. So now, as you can see, I've got this in order from squared to just a singular variable to no variable at all. So that's what we call standard form when we are listing out our expressions with the highest exponent first and then working our way down. All right, last example here. We've got 5ab squared, a squared b, 3ab squared. Okay, lots of a's and b's and squareds. Now, I mentioned before that you'll want to start with your highest exponent and work your way down. Well, the highest exponent is just a squared term. So then the next step, I guess, of that is to look at these terms in alphabetical order. So since we have an a squared term, and then just b, the b is singular, that goes along with the a squared, and then we have a b squared that goes along with just a singular a. This term with the a squared and then the singular b multiplied together, that's actually going to be our first term. Because a comes first in the alphabet, that's the one that is squared. So we want to look for the higher exponent with that, that first letter that comes in the alphabet. So let's see if we have any other a squared b terms. And I see one right here. We've got a squared b right there. Okay, so let's put these two together. 1a squared b plus 7a squared b gives us 8a squared b. Okay, and then I'm done with those. And then my next two, my last two terms are the same terms. They are like terms. We've got an a, singular a, and b squared, and then a, b squared. So I'm going to go ahead and put those two together. So they're both positive, so 5 plus 3 gives me 8. And we've got ab squared. Okay, there you go. That is how to simplify some expressions. Please let me know what you thought in the comments. This is part of my pre-algebra series. I have a lot of videos all over different pre-algebra skills. So please check out that link in the description, and I'll see you next time.